June 17th, 1944. Just inland from Juno Beach, the morning fog rolls low across a battered French field. The soil is still torn by shell bursts from the week before. A tractor engine coughs in the grey light. A grader scrapes its final pass. And in the distance, the silhouettes of Canadian construction sappers, men who only months earlier were cutting timber in British Columbia or hauling logs in northern Ontario, wipe dust and rain from their faces as they finish the last section of metal matting. Then it happens. A single RAF Spitfire drops out of the mist, wheels down, gliding toward a runway that didn't exist 3 days ago. Its tires hit the steel mesh with a sharp metallic hiss. British and Canadian officers watch in stunned silence as the aircraft rolls to a stop, refuels, and takes off again, back into the fight. Hours earlier, German reconnaissance teams had photographed this exact field. They reported it would take the Allies 3 weeks to build a usable airstrip here. They were wrong. Canada's lumberjack engineers had done it in just 3 days, and this was only the beginning. To understand how a group of Canadian lumberjacks could carve a combat-ready airfield out of a ruined Norman pasture in just 72 hours, we have to travel back 4 years, to a moment when Canada made a decision that quietly reshaped the entire Allied war effort. It began on December 17th, 1939, only months after war was declared. Britain faced a crisis. It needed pilots, thousands of them, and it needed airfields to train them on, far from German attack. The solution came from across the Atlantic. Canada, with its limitless land, stable skies, and vast pool of skilled tradesmen, agreed to create what would become one of the largest aviation programs in history, the British Commonwealth Air Training Plan, BCATP. It was called the Aerodrome of Democracy, and it required a miracle of construction. Across the prairies, Manitoba, Saskatchewan, Alberta, survey teams, engineers and contractors fanned out across open grasslands and frozen farmland. Their orders were simple and staggering. Build airfields. Dozens. Hundreds. Build them fast. Build them in blizzards, in mud, in heat. Build them to a standard so precise that a pilot trained in Calgary could land on the same pattern of runways in Moncton or Moose Jaw without hesitation. The pressure was enormous. Between 1940 and 1943, over 100 airfields and relief landing grounds appeared across Canada in a wave of construction rarely seen in the nation's history. But where did the manpower come from? From the forests. Canada's lumber and logging industry, one of the most rugged workforces on Earth, shifted its strength toward the war. Thousands of men who had spent their lives falling timber, hauling logs and building remote winter roads joined the Royal Canadian Engineers, the Air Force construction units, or civilian contracting teams. Others joined the Canadian Forestry Corps, whose work provided the vast timber required for hangars, barracks, control towers, fuel depots, crates and bridges. They brought with them something no textbook could teach: an instinct for land, how it drained, how it froze, how it buckled under weight, how to stabilize soil with speed and improvisation. Skills learned not in universities, but in logging camps where a misread slope or a soft patch of ground could cost lives. This mattered, because the only way to build airfields at the pace Britain needed was to standardize everything. By mid-1941, Canada had perfected a formula: 3 runways, each at fixed lengths and angles, prefabricated hangars shipped by rail, portable lighting and wireless huts ready to assemble on arrival, uniform drainage plans tested on frozen prairie soil, road and fuel layouts identical across dozens of bases. When a new site was approved, the process became almost ritualistic. Survey teams arrived 1 week. Bulldozers arrived the next. Within days, the land was cleared, levelled, packed and grooved. Lumber mills worked around the clock. Rail cars delivered steel, gravel and fuel by the thousands of tons. The prairie provinces became a proving ground for something the world had never quite seen before: an air force capable of lifting itself off the ground almost as fast as it could plan a mission. By the end of 1943, more than 130,000 aircrew had trained in Canada. Not just pilots, but navigators, wireless operators, bombardiers and mechanics. They trained in skies uninterrupted by enemy action, on runways built by Canadian hands that had become frighteningly efficient at speed. And with every new airfield, Canadian engineers learned a lesson that would become priceless on the shores of Normandy: how to build on soft ground, how to build in winter, how to build with minimal materials, how to build when the clock was merciless, how to build when the weather refused to cooperate. They learned how to turn emptiness into infrastructure. This is why, in 1944, when the Allies needed airstrips in France faster than the German army could react, they turned instinctively to the engineers who had already built dozens of them in the wild heart of a continent. Canada had not merely produced airmen. It had produced the fastest airfield builders the Allies possessed, and the war was about to put that skill to its ultimate test. When Allied troops stormed ashore on D-Day, they brought with them not only tanks, guns, and men, but a radically different philosophy of air power, one born in part from Canada's vast wartime construction program. To understand why German engineers were stunned by Canadian speed, we must compare the two systems that collided in Normandy. For the Luftwaffe, airfields were monuments, long-term, fortified installations built for permanence and precision. Since the 1930s, Germany had invested heavily in concrete runways, underground fuel systems, reinforced hangars, and elaborate dispersal bays. These airfields were masterpieces of pre-war engineering, designed to survive years of operations and withstand attack when possible. But they came with a weakness. They required time, weeks for survey, weeks for excavation, weeks for pouring concrete, and even more weeks for curing, grading, and construction of operational buildings. A single Luftwaffe combat base often required thousands of laborers, including many conscripted or forced workers assigned to Organization Todt. By 1944, with resources stretched and Allied bombers pounding German industry, these projects slowed even further. Where once the Luftwaffe could expand across Europe with confidence, now every new airfield was a struggle. The German style assumed one thing: that front lines moved slowly. The Allies believed the opposite. By 1943, the Allied approach had evolved into something radically different: the concept of the Advanced Landing Ground, or ALG. These were not permanent air bases. They were temporary, mobile, and expendable. Their purpose was simple: put Allied fighters and fighter bombers as close to the front as possible, as fast as possible. To achieve this speed, the Allies relied on innovations the Germans never fully embraced. First was soil engineering. Rather than waiting months for concrete, Allied engineers stabilized earth using gravel, sand, compaction rollers, and drainage ditches. On top of this came the real revolution: portable runway surfacing. Two materials changed everything: square mesh track, SMT, welded steel mesh unrolled like netting across the prepared soil, pierced steel planking, PSP, heavy, perforated metal plates that locked together to form a runway capable of supporting fighters, bombers, and transport aircraft. With these materials, an airfield could be built in 2 to 5 days, depending on ground conditions. In rare cases, like the Canadian-built strip after D-Day, runways appeared in under 72 hours. What shocked German observers was not only the speed, but the simplicity. Their doctrines assumed runways required concrete. Anything less was temporary, unreliable, and unsafe. But the Allies didn't need perfection. They needed availability. They needed proximity. They needed fighters in the air, not engineers waiting for cement to dry. This adaptability matched Canadian experience perfectly. Men who had built BC-ATP airfields across the prairies were masters at reading land quickly, improvising drainage, adjusting contours, and exploiting whatever materials were available. Where German engineers saw problems in a Norman pasture, soft soil, hedgerows, uneven ground, Canadian crews saw a familiar challenge. Their approach was practical, not doctrinal. If the land was wet, drain it. If the soil was soft, compact it. If hedgerows blocked access, cut them. If the surface needed reinforcement, unroll SMT and begin matting. This mindset, simple, rugged, and relentlessly efficient, allowed Canadian and Allied engineers to transform captured French farmland into fighter bases almost overnight. For the Germans, whose reconnaissance doctrine relied on observing enemy construction and estimating timelines, this was a nightmare. Their predictions were routinely wrong. Airfields they believed weeks from completion suddenly hosted entire squadrons of Typhoons or Spitfires. Bombing raids arrived from aircraft they didn't even know had forward bases. And with every new ALG, Allied air power crept closer to the front lines, tightening the noose around German mobility. By the end of June 1944, the Luftwaffe wasn't just outnumbered, it was outbuilt. Canadian engineering had shown that warfare was no longer only about destroying infrastructure. Sometimes victory belonged to the side that could create it faster. They were not glamorous soldiers. They didn't carry rifles into the first wave at Juno Beach or drive tanks through Car. Instead, they arrived with saws, axes, graders and bulldozers. Yet without them, the Allied advance would have stalled before it ever reached the German defensive lines. The men who built Canada's wartime airfields, and later the ALGs in Normandy, came largely from a world defined by timber, British Columbia's interior, Ontario's vast northern forests, Quebec's rugged logging camps. These were places where winter was brutal, labour was physical, and mistakes were unforgiving. Logging demanded instinct, an instinct for slope, soil, weight and drainage, an instinct for machinery that had to be repaired in the cold with whatever tools were available, an instinct for endurance. 10-hour days, swinging axes, hauling timber, building roads through muskeg and riverbed. When these men joined the Royal Canadian Engineers or airfield construction groups, they brought a skill set that turned out to be priceless. They already knew how to build infrastructure where infrastructure shouldn't exist. In France, this mattered. Normandy's farmland looked nothing like the orderly training fields of Canada. Yet the challenges were familiar: wet soil, clay patches, soft ground that sucked at machinery, hedgerows thicker than timber walls. Sappers who had spent years navigating forest obstacles simply cut, graded, burned, drained, and moved forward with a confidence foreign to many European engineers. They were used to making decisions in minutes, not days, because in the logging world, hesitation cost daylight, and daylight was money. And on the battlefields of Normandy, daylight was survival. These men were often dismissed by German intelligence as labourers, woodsmen, or even lumberjacks. But that label only captured half of who they were. These were craftsmen of terrain, builders shaped not by academia, but by the raw demands of Canadian wilderness. That wilderness training became the foundation upon which 3-day airfields were built. To German planners, airfields were static assets, important, valuable, but immobile. To Allied planners, especially after years of fighting in North Africa and Italy, an airfield was something far more dynamic, a weapon of mobility. Every new runway built in Normandy changed the tempo of the war. Every kilometre closer to the front reduced the time it took for Canadian and British fighters to reach the battlefield. A Spitfire based in England might take 25 to 30 minutes to reach northern France. A Spitfire based on a freshly built ALG could be overhead in 5 to 7 minutes. This wasn't just efficiency, it was dominance. Normandy's terrain was dense and compartmentalized. German columns often moved at night, relying on forest cover and narrow country lanes. Spotting and striking these movements required aircraft on station at short notice. The closer the airfields moved to the front, the more missions the Allies could launch each day. Some ALGs supported 4 to 6 sorties per aircraft per day, an impossible rate from long-distance bases in Britain. Canadian airfields, such as B3 at Saint-Croix-sur-Mer and B4 at Bagny-sur-Mer, became hives of activity almost immediately. Typhoons thundered off the short, steel-matted runways, carrying rockets and bombs designed to tear open German armour formations. Spitfires patrolled the skies overhead, denying the Luftwaffe even the possibility of daylight intervention. Each airfield was a spearhead of air power, moving firepower forward, denying German movement, supporting advancing infantry minute by minute. And because Canadian engineers could build these runways so quickly, they turned air power from a distant resource into a constantly shifting presence, an asset that adapted as fast as the battlefield itself. In Normandy, airfields weren't rear area installations. They were front-line weapons. Constructing an ALG in Normandy wasn't like building in Canada. There were no peaceful horizons, no distant tree lines, no isolation from danger. The moment ground forces secured an area, even partially, engineer units followed close behind. Many arrived before the smoke had even cleared. The first hours were the most dangerous. Sappers swept for mines and booby traps laid by retreating German infantry. Bulldozer operators worked with nerves of steel, pushing earth over terrain in full view of enemy observers. Artillery shells were not uncommon. Sniper fire occasionally cracked through the hedgerows, but the work did not stop. Runways were built in shifts. Day, night, rain, mist, artillery, no matter the conditions. Flood lamps were forbidden due to German air attack, so men often worked under blackout conditions, guided only by lamps hooded in canvas or the faint glimmer of dawn. There were no pauses, no excuses. If the airfield wasn't ready, the infantry would go without air cover. Canadian engineers laid SMT and PSP by hand, kneeling on metal strips that baked in the sun or chilled under evening fog. Trucks backed in with gravel and sand. Rollers moved up and down the freshly graded lanes. Mechanics serviced generators while surveyors rechecked compass bearings. Every man knew his role, and every role was essential. Then, in a moment that always seemed surreal, the chaos would fade. The matting would lock into place. Guidelines would be painted. Fuel bowsers would arrive. A windsock would rise from a pole still smelling of fresh-cut timber. The runway would come alive. Pilots who had been operating from England only days earlier would now land minutes from the front lines, stepping out onto a field still warm from the friction of bulldozer tracks. These were airfields built under fire, constructed with urgency, courage, and the unspoken knowledge that every hour saved meant lives preserved. The true secret behind three-day airfields was not brute force alone. It was engineering innovation. The Canadian and British construction units relied on two remarkable materials that transformed warfare: square mesh track, SMT, and pierced steel planking, PSP. Normandy's fields were never meant to carry aircraft. They were dense clay in some regions, soft loam in others, and sodden from early summer rains. Heavy machinery bogged down easily. Fighter aircraft, loaded with rockets or fuel, could cut deep ruts in minutes. Left untreated, the ground simply could not sustain operations. But engineers didn't need perfect ground. They needed stable ground, fast. First came drainage. Logging veterans understood water. They dug ditches instinctively, knowing exactly where water would pool after rain. Bulldozers then shaved down high spots and filled low ones, creating a uniform grade. Gravel was brought in, compacted, rolled and tested. Then the transformation began. SMT, light steel mesh, was unrolled across the surface like an enormous fishing net. It bonded with the soil beneath, distributing weight, preventing sinkage, and locking the terrain into a stable layer. On top of this, engineers laid PSP, thick metal panels with perforated holes that interlocked like armor plates. PSP could bear the weight of a fully loaded Typhoon, even on ground that would collapse under a truck. To German engineers, this was baffling. They had concrete, they had asphalt, but they did not have a portable runway in the boot of a transport truck. Allied engineers carried their runways with them. The Luftwaffe had designed for permanence. The Allies had designed for speed. In Normandy, speed won. Canadian units could build airfields on ground the Germans would have declared unusable. Wet meadows, orchards, clay ridges, and even bomb-cratered pastures. Technology didn't replace manpower. It multiplied it. And it let Canadian engineers achieve what the enemy considered impossible. Airfields don't appear in isolation. They are part of a larger rhythm, a choreography that merges maps, intelligence, logistics, and opportunity. In 1944, the Allies changed the very nature of this choreography. Before D-Day, engineer officers pored over aerial photographs, drainage surveys, and pre-invasion reconnaissance. Hundreds of potential airfield sites were identified across Normandy, each coded, evaluated, and filed for use the moment they were captured. This planning system had no equivalent in the German war machine. Luftwaffe engineers built for territory they already controlled. Allied planners built for territory they intended to take. When Canadian and British ground forces advanced, engineer units followed a script written months earlier. Trucks loaded with matting, generators, fuel drums, windsocks, tents, and construction tools rolled ashore, knowing exactly which field would become B3 or B4. But there was more to it than maps. Canadian leadership understood adaptation. Fields often looked different from the photos. Hedgerows thicker, soil wetter, gradients sharper. Yet decisions had to be immediate. Experience from the BCATP taught officers to assess ground at a glance and direct crews with precision. Logistics also played a defining role. Fuel convoys, ammunition trucks, mobile workshops, water carts and radio vans all had to converge on the new airfield at exactly the right moment. Delays meant grounded aircraft. Grounded aircraft meant infantry without air support. Even local French civilians contributed, bringing farm tools, carts, and sometimes even their own labour to help clear rubble or move timber. This combination of foresight, flexibility, and decentralised problem-solving made Canadian airfield construction a living organism, one that adapted with each mile gained in Normandy. Where German engineers saw chaos, Canadians saw opportunity. Where German doctrine demanded precision, Canadians demanded progress. The map was moving, but so were they. For the German High Command, the Normandy campaign was already a nightmare, but nothing unsettled their intelligence officers more than the speed at which Allied airfields appeared behind the beachhead. German reconnaissance aircraft flew high over the front, taking photos of areas recently secured by Canadian and British troops. Analysts studied these images and estimated timelines based on their own construction doctrine. 2 to 3 weeks for an operational airbase. Longer if the ground was soft. Then the reports came in. Panicked, disbelieving, sometimes contradictory. Fighter bombers were launching from locations the Luftwaffe believed unfinished. Typhoons were striking German columns earlier than expected. Spitfire reconnaissance flights were appearing from directions that made no sense. At first, German engineers assumed the Allies were reusing existing French strips. Then they assumed the photos were misinterpreted. Then, finally, reality settled in. The Allies were building airfields faster than the Germans could react to them. To the Luftwaffe, this was more than a tactical frustration. It was a psychological blow. Their entire defensive model relied on predicting enemy capabilities. Now prediction had become impossible. Divisions moving at night found themselves under sudden attack at dawn. Supply convoys that had moved safely one day were destroyed the next. Even German armoured units, designed for rapid movement, felt pressure from fighter bombers that seemed to take off from thin air. Post-war German officers would write with admiration and disbelief about the Allies' ability to build airbases in the shadow of battle and begin operations within hours. Canadian sappers were not just building runways. They were dismantling German expectations and turning engineering speed into a weapon more devastating than any bomb. The construction of an advanced landing ground was always a race against German artillery, a race against time, a race against the expectations of an enemy who believed such a feat was impossible. One of the most revealing examples unfolded just days after the landings, on ground barely secured by Canadian and British infantry. The field had been a pasture, its grass flattened by shell fire, its hedgerows torn open by tank tracks. A few cows still wandered nervously at the edges, confused by the sudden roar of machinery. Day one began before sunrise. The ground was still damp from the night's mist. Canadian engineers fanned out across the area, marking a rough rectangle with stakes hammered into the soil. Behind them, mine clearance teams worked methodically, crawling on hands and knees through the grass, probing every suspicious patch. Bulldozers growled forward, massive yellow beasts that announced the beginning of transformation. They carved long, straight lines across the earth, shaving down humps of dirt, pushing aside debris, and turning a chaotic battlefield into something resembling order. Graders followed closely, levelling the soil into a surface that could one day support the weight of warplanes. All the while, German artillery barked from positions farther inland. Shells landed unpredictably, sometimes far off, sometimes close enough to shake dust from machinery. But the work continued. Every hour gained meant the runway would open sooner. Every hour lost meant the infantry would advance without the shield of air power. By nightfall of day one, the field no longer looked like a field. It looked like potential. Day two began with urgency. Gravel trucks lurched into place, dumping tons of crushed stone onto the graded surface. Men with rakes and shovels spread the material under the direction of supervisors who paced up and down the proto-runway, adjusting contours by instinct. Drainage trenches were cut into the soil at precise angles. Logging wisdom applied to French farmland. Water fled the surface, guided away before it could sabotage the next stage. Then came the heart of the operation, the matting. Rolls of square mesh track were unspooled across the ground like wire carpets. Men knelt beside them, driving pegs into the earth, flattening curls, connecting edges. In the rear, stacks of pierced steel planking waited, each sheet a heavy slab of perforated steel, dented and scarred from previous campaigns. Crews worked in pairs, hooking one PSP panel to another in long, shimmering lines that stretched across the runway like a spine of metal. It was exhausting work. Knees bruised against steel, gloves tore, sweat dripped into the dirt. But slowly, piece by piece, the runway took shape. At noon, a German reconnaissance plane circled high overhead. Cameras clicked. German analysts would later study the photos and estimate the runway's completion date at no sooner than 2 weeks. They never imagined what would happen the next day. Day 3 began in silence. A fog bank rolled in from the channel, muffling the world. Canadian engineers moved through the whiteness like figures in a waking dream. The matting was nearly complete. Rollers thudded across the surface, compacting the final sections. Surveyors checked alignment. Mechanics tested generators for radio huts and fuel pumps. By mid-afternoon, the windsock rose. A small thing, but symbolic. An airfield had come alive. Moments later, the unmistakable growl of a Rolls-Royce Merlin engine echoed through the mist. A Spitfire descended. Its landing gear extended. The Canadian engineers paused. After 3 sleepless days, this was the moment everything became real. The fighter touched down smoothly, rolling across the brand-new runway with a soft metallic hiss. Ground crews swarmed it. Fuel, ammunition, checks. And within minutes, the aircraft was airborne again, racing off toward German positions. The airfield had been operational for less than 10 minutes. Already it was changing the battle. German observers, receiving reports of Allied aircraft operating from the newly built strip, refused to believe it. Their calculations were clear. No one could build an airfield that fast. But someone had. Canadian lumberjacks had done it in 3 days, rewriting the rules of modern warfare. The 3-day airfield was not an isolated miracle. It was the beginning of a chain reaction, one that rippled across Normandy and reshaped the tempo of the entire campaign. As the Canadian and British armies pushed inland, engineer units leapfrogged behind them, carrying with them the materials, machinery and muscle to repeat the process again and again. Every new field followed the same pattern. Identify, clear, grade, drain, mat, mark, fuel, fly. To the Allies, this process was routine. To the Germans, it was alarming. By the 3rd week after D-Day, the Anglo-Canadian sector alone had multiple operational ALGs, each built at staggering speed. Airfields that German intelligence assessed as in early preparation were suddenly launching Spitfires at dawn. Fields they believed would take weeks to finish were declared operational in 72 to 96 hours. Even damaged Luftwaffe bases, abandoned by retreating German units, were rebuilt by Canadian crews with uncanny efficiency. Bomb craters filled, taxiways cut from farmland, steel matting laid over the ruins of concrete. The rhythm was relentless. Canadian construction groups moved like a tide, flowing behind the infantry and armour, their progress measured not in kilometres but in hours saved. Wherever the front advanced, a new airfield appeared, sometimes before German defenders even realised the land had changed hands. This speed created a problem the Luftwaffe had no solution for. Predictability collapsed. German aircraft attempting to strike Allied positions found themselves intercepted earlier and more frequently. Columns moving toward Caen or Falaise were hit by typhoons that had taken off only minutes earlier. Luftwaffe pilots reported being bounced at altitudes and angles inconsistent with aircraft launched with Britain. Intelligence officers struggled to update their maps fast enough to reflect the new operational ranges. Every time the Germans recalculated, the Canadians built another airfield and invalidated the numbers. The psychological effect was profound. German artillery commanders began assuming that any lull in Allied air activity would be short-lived. Armoured units learned to move only at night or under forest cover. Logistics officers, already strained by fuel shortages, found their convoys shredded by aircraft operating from what seemed like invisible bases. Reports from frontline divisions described the Allied air presence as unavoidable, instantaneous, and impossible to escape. This was the strategic consequence of fast construction. Air superiority stopped being a condition of battle and became the environment of battle. Canadian engineers were not on the front lines firing rifles. They were in the rear, covered in mud and oil, working through exhaustion and artillery bursts. Yet their work determined whether fighter bombers could launch 3 missions per day or 6, whether an armoured counterattack arrived intact or in pieces, whether German reinforcements reached Caen in strength or bled out along the route. And as the airfields multiplied, something else became clear. Canadian speed forced the Luftwaffe into strategic retreat. They could not contest the skies because they could not contest time. No matter how skilled their pilots, no matter how advanced their aircraft, the Germans were tethered to a system that required weeks to build what the Canadians could produce in days. By August 1944, the Allied advance was accelerating. Airfields moved eastward like stepping stones across France. Each one shortened the distance to the fighting. Each one expanded the reach of Allied air power. And each one weakened the Luftwaffe's ability to respond. It wasn't just that Canadians could build faster. It was that their speed rewrote the operational map every few days, turning Normandy into a battlefield where the Germans were always one step behind. And in modern warfare, being one step behind means losing the war. By the end of June 1944, the effects of Canada's rapid airfield construction were undeniable. Air power was no longer something that arrived from distant British bases across the Channel. It was a constant, immediate presence hovering above the battlefield. And that shift changed everything. The first and most obvious consequence was operational tempo. With airfields only minutes from the front, Allied aircraft could launch far more missions per day. A single Typhoon or Spitfire, once limited to 2 or 3 sorties while flying from England, was now capable of 4, 5, even 6 combat missions in a single day. That meant more reconnaissance, more close air support, and more interdiction attacks against German reinforcements. For German ground forces, this translated into a near-continuous threat from the sky. Armoured columns attempting to manoeuvre behind the lines found themselves repeatedly struck by rocket-firing Typhoons. Transport convoys, fuel trucks, half-tracks, artillery tractors were cut apart on roads that had previously been safe during daylight. Even small unit movements became hazardous once Allied aircraft could appear overhead in minutes. This was not just a tactical annoyance. It was a strategic disruption. German commanders complained that they were being forced to fight blind and exposed. Divisions that might have mounted effective counterattacks against the advancing Canadians and British instead arrived shattered, scattered, or late. Their timetables collapsed under the pressure of air superiority that grew stronger with every new airfield built. But the Allied advantage came with a cost, one paid by the men who built these runways. Canadian engineer units suffered steady, often overlooked casualties throughout the Normandy campaign. They were not infantry, yet they worked at the very edge of combat. Shellfire targeted them whenever German observers spotted bulldozers or construction convoys. Mines laid in fields and orchards claimed the lives of sappers clearing ground for runways. Snipers fired at survey teams. Air raids occasionally struck the construction zones where men knelt over steel matting or dug drainage trenches. Their work was essential, but rarely celebrated. There were no medals for the man who spent 3 days without sleep grading soil under artillery fire. No public recognition for the logging veteran who laid PSP panels while shells burst nearby. Their victories were functional, measured in sorties flown, not headlines written. Yet the impact they had on the broader campaign cannot be overstated. Every runway built helped compress the Luftwaffe's operational space. Every airfield denied German forces a window of maneuver. Every increase in sortie rate accelerated the collapse of German logistics. By early July, German commanders no longer believed they could regain the initiative in the air. By late July, many doubted they could even move safely during the day. And by August, the rapid Allied advance, which pushed across France and toward the Seine, was inseparable from the air power that Canadian engineers enabled. The aftershock of fast-built airfields rippled far beyond Normandy. It reshaped German defensive planning, disrupted reinforcement schedules, and forced commanders into reactive posture. In a war where mobility and timing were everything, Canadian engineering had quietly stolen both from the enemy, and the consequences were only just beginning. When Normandy finally broke open in late July and early August 1944, the Allied armies surged forward across France with a speed that stunned even their own planners. Behind them, like a shadow advancing across the map, came the construction units, Canadian, British and American, building new airfields almost as quickly as the front moved. For the Canadians, this momentum felt familiar. They had practiced it for years across the prairies, constructing airfields where none existed, in weather far harsher than anything Normandy could offer. Now they applied that experience to every village, orchard and meadow they encountered. As the Anglo-Canadian armies crossed into Belgium and the Netherlands, the pace did not slow. Advanced landing grounds multiplied across liberated territory. Some were built on abandoned Luftwaffe bases. Others were carved from farmland that had never seen an aircraft before. A few even operated for only weeks before being closed and replaced by new ones closer to the action. This constant movement carried a deeper significance. It represented a new philosophy of air warfare. Before the war, airfields were fixed nodes, permanent installations, immovable assets that determined the reach of an air force. By 1944, the Canadians had helped transform that concept completely. Now air power was fluid. It shifted with the battle. It grew, contracted, and pivoted based on opportunity. It was no longer tied to geography. This flexibility became part of Canada's post-war military doctrine. Veterans who had built runways under fire returned home and joined engineering units, civil aviation projects, and northern infrastructure initiatives. The techniques refined in wartime, rapid soil stabilization, prefabricated structures, modular layouts, and the use of lightweight metal matting, appeared across civil airports, northern radar stations, and remote Canadian communities. But the human legacy was just as important. Among the men who built those three-day airfields, the war's memory did not center on glory. It centered on purpose. They watched pilots take off from runways they had created and knew those missions were possible because of their work. They witnessed aircraft landing safely on strips that, just days earlier, had been muddy pastures filled with mines and shell craters. They saw infantry saved by the close air support they had enabled. These were victories built from timber, sweat, steel, and instinct. Many veterans never spoke loudly of what they did. They were not the ones front and center in newsreels or official photographs. Yet their contributions shaped the Allied advance in ways far greater than most civilians ever understood. By the time the war ended, the Luftwaffe was a shattered force, grounded not only by combat losses, but by the simple truth that it could no longer operate in a world where the enemy could build airfields faster than Germany could destroy them. This was the quiet triumph of Canadian engineering. An enemy who believed it took weeks to build a runway was beaten by men who could build one in days. An army that relied on concrete was outpaced by soldiers who relied on skill, and a war that demanded destruction was influenced profoundly by those who built. The lumberjack engineers left behind no monuments, only the ghosts of runways across Normandy and northern Europe, now reclaimed by grass and silence. But their legacy endures in every modern airstrip built quickly, every forward base erected in remote terrain, every military engineer trained to think not in terms of months, but in days. Their work proved a simple truth. Speed can win wars, even when measured in shovels and steel. War is often remembered for the moments of violence, the battles, the explosions, the clashes of armies struggling for ground. But sometimes history turns on quieter acts, on hands gripping tools instead of rifles, on men who build instead of destroy. The Canadian engineers who carved airfields from the soil of Normandy are part of that quieter history. Their runways did not roar with battle cries. They hummed with the engines of aircraft lifting off to protect soldiers miles away. Their victories did not come from firing weapons, but from finishing a task before the enemy could understand what was happening. In a war defined by technology and brutality, these men proved that ingenuity and endurance could be weapons of their own. What they achieved in 3 days was more than a feat of engineering. It was a shift in the very nature of warfare, showing that mobility, speed, and adaptability could overpower even the most rigid doctrines. German engineers tried to predict the future based on their own timelines. Canadian builders rewrote those timelines entirely. Today, the fields of Normandy are quiet. Cows graze where typhoons once roared. Grass covers the PSP and SMT that once formed the backbone of hastily built runways. There are no signs marking where Canadian hands shaped the land into a launching point for liberation. But the legacy remains. etched into military doctrine, civil engineering, and the memory of a war won not only by those who fought, but by those who made victory possible. The lumberjack engineers of Canada taught the world a lesson that still resonates. Sometimes the most powerful act in war is not tearing something down, but building something up, and doing it faster than anyone believes possible.